They twinkle. They inspire. They bring alive the night sky. Thousands of stars bright enough to be seen on a clear night. But in reality, there are more than 100 billion stars just in our Milky Way galaxy. And the deeper we look into space, the harder it is to see past so many stars. The glare from all of those suns blinds us from seeing what else is really out there.
When you're trying to look for Earth-like planets next to sun-like stars, in those cases, the reflected light from the planet is about 10 billion times fainter than the light of the star. It's a tremendous challenge, and this is why star shades are really compelling as a way of addressing this challenge.
Aerospace engineer Manan Arya has been working for years on a galactic puzzle: how to block starlight in a universe that contains up to 1 septillion stars. A solution, says the assistant professor at Stanford University, lies in an ancient form of art: folding paper.
Origami teaches us how to fold very large, thin sheets into very small spaces, and that's exactly what space engineers need.
We met with Manan at the Off-World Bar, a space-themed venue in Toronto, to learn more about how origami can reveal worlds we know are out there but cannot see.
The reason we need origami for space applications is because we want to launch structures in space that are just amazingly big. So being able to fold these structures such that they fit neatly within our rocket and then unfold when they get to space.
His fascination began when he was a kid. Born and raised in New Delhi, India, Manan dreamt of one day going into space.
You had dreams of being an astronaut as a child. Was it a possibility?
Oh gosh, no. I've met people who are qualified to be astronauts, and I've met some astronauts. I am not of that flavor of person.
Because?
I like to sit and think for a long time before I take actions. I'm terribly not useful in emergencies.
Did you think that if I can't be an astronaut, there's a way that I can find my way in here?
I had dreams that maybe it'd be fantastic if I could go to NASA and maybe contribute there. I never actually thought it would happen, but it kind of did.
It would be a long journey to realize his dreams. In 2003, Manan and his family moved to Canada, where he attended high school and then the University of Toronto. It was there he became enamored with studying structures.
I became fascinated with these kinds of spacecraft called solar sails, which are spacecraft that unfurl these large sails that use the pressure of sunlight to generate thrust. Light bouncing off objects produces thrust. The problem is the pressure of sunlight, the thrust you get from the solar sails, depends on how big your sail is. And for these tiny, small satellites, trying to fit a very large sail into these small satellites required, some interesting engineering. And that's what led me to origami. The problem of trying to fold these, 10 by 10 meter sails into a spacecraft the size of a bread box.
Manan calls it the suitcase problem. But instead of packing clothes, it's how much expandable technology you can cram into a small space capsule.
This is the Mira Ori fold.
The Japanese art of paper folding has a long history, dating back thousands of years. Now its principles are being used in many different fields, including aerospace.
It was really in the 60s and 70s when mathematicians and academics got interested in the art of origami. And since that time, they've developed this fantastic tool set of ideas that were available to me that I could just pick up and run with.
Manan brought his interest in origami to Caltech, the California Institute of Technology. Caltech manages NASA's Jet Propulsion Laboratory, known as JPL. And after graduating, Manan went to work on Starshade.
Starshade is a fantastic application of kind of origami engineering. A starshade is a mechanism by which we can block out the light of a star so we can observe faint planets that are orbiting that star. What would be really fantastic is if you could take pictures of these planets, of these exoplanets. The challenge is these planets orbit these bright, pesky things called stars, which are much, much brighter than the planet. Starshade is a way where we can block out that glare so we can see those faint planets next to it.
Tell me how that works.
It's almost as if you've taken a shade and put it in front of the camera, the telescope in this case, and the shade blocks out exactly the light of the star while letting the light of the planet pass by the side of the shade.
At the side of the shade?
Exactly. It's not coming through it, yeah. It's like if you're trying to look at something really close to the sun and you put your thumb up to block out the sunlight so you can see, let's say, a bird or something like that.
Flying with a space telescope, the star shade would use thrusters to put itself in a position to block a star and allow the telescope to capture images. According to Manan, when fully unfurled, star shade would be roughly the size of a baseball diamond. But to get into space, it needs to fit into a rocket about 5 meters in diameter. That's where origami comes in.
How big is it going to be when it's in its folded up stage?
Maybe the size of an SUV.
How are you coming along?
Oh, fantastically. I should point out, Starshade is not an official NASA mission. It is a technology that we're developing such that we have it in our back pockets for future missions.
NASA has had success using origami already. The powerful James Webb Telescope's main mirror and sun shield had to be folded up to be launched into space. And the pictures it's sending back can only be inspiration for Starshade. As for Manan, his curiosity with the traditional art has only grown.
The motivation behind making structures like these was to make foldable robots for space exploration.
Now in his lab at Stanford, he's applying the same techniques to engineering biomedical devices and robotics. From creating innovations to discovering faraway worlds, much of what Manan is doing today may lead to unimagined breakthroughs years from now.
Parts of me that wish that my work would have more immediate impact. At the same time, I'm satisfied with the idea that I'm doing work that is foundational for the next generation of technologies. The things that I'm working on may not come to light, or if they do, they may come to light a long time from now.
But so far?
Oh, so far it's been a wild ride. It's been fantastic.